All right, welcome to physics. We are now continuing on with our conversation about forces. And so the focus for this activity, activity number two, will be net force and free body diagrams. The feedback I got is that a lot of us are feeling uh, pretty okay about this forces so far and then free body diagrams, or maybe we've seen them before. So that's great. And so hopefully this will just help us feel more confident in both of those categories. It is really the foundation of how you're going to support yourself in drawing these diagrams and representing scenarios before we start adding some calculations, which I'm touching on a little bit at the end of this activity. So uh, there's going to be 10 questions. And again, I have a little bit of notes and reminders for you that will help you through the questions. First, though, if you are feeling maybe not as confident with the free body diagrams, I've included this video here for you. It's only 4 minutes long. It's I'm calling it optional, but I really recommend it if you're really having any questions about some of the ins and outs of free body diagrams. So, again, 4 minutes, I highly recommend you watch it. Next, a couple reminders. This was from our activity number one when we introduced what a net force is, what forces are, and how it relates to motion. So, just a reminder, the net force is a combination of all forces acting on an object. And if there is a net force greater than zero, that means there's going to be a change in the motion of the object. If the net force is zero, then that means it's at equilibrium and there's no change that's going to occur. There's no motion that's going to occur. Something kind of in addition, I think we touched on it, but in addition, calculating the net force. So if the forces are pushing or pulling in the same direction, then you add the forces together, right? That's like me and my buddy are pushing on an object. We're both applying a force in the same direction. So it's like you're adding our force together. Uh, the opposite, okay, if the forces are pushing or pulling in the opposite direction, then you have to subtract the forces. And what that really means, right? If the forces are the same, you're going to end up with zero. And if one is greater, then it's going to take over the opposite force. So a few examples here, that doesn't help. Okay, we have 1,200 newtons going upwards. Okay, we then have the force of gravity pulling downwards at 800 newtons. So the easiest thing to do is take the largest number. Okay, 1,200 is greater than 800. So 1,200 going up minus 800 down leaves you with 400 newtons in the upward direction. This middle scenario here, okay, we have air resistance going up at 600 newtons, force of gravity going down at 800 newtons. And so 800 down minus 600 up leaves you with 200 newtons going down. So this object is falling. Okay. Again, this is telling us about the motion. So if this is 400 up, then we know that this, and it says tens. So that stands for tension. So there's a tension force, which means there's a rope or a spring that is pulling up at 1,200 newtons, and it has 400 newtons extra. So this is an object that is getting pulled up by a rope or a chain, possibly. This then is an object that is falling to the ground at 200 newtons. Okay. And this one, okay, F normal is another way of saying that support force. And then F gravity, okay, are canceled out. So this object is at rest on the floor. But then we see we have friction at 200 newtons going left and no force going right. So that means we're going to have 20 newtons of net force to the left. So that then is a little reminder and tutorial on some of these scenarios. So determine the net force in the scenarios provided. So again, you can enhance these. Again, if they're in the same direction, you're going to add them. If they're in opposite directions, you subtract them. Then the biggest hint I can give you for all of these is don't forget to include units. Your answer should be a number in newtons, which again, as you can see here, is represented by N. And if there is a direction, you need to include that. So up, down, left, or right would be your options. So again, each scenario is going to be a little different, so make sure you read the numbers carefully. I would encourage you to show your work so I can give partial credit. Okay, and again, each one's a little different. Then I want you to practice your own free body diagrams. We touched on this a little bit already, just doing a couple more. So if calculations are necessary, then I want you to remember these pieces of information. One, this is probably the most important, force equals mass times acceleration. We also touched on the acceleration due to gravity. So this is pretty much, unless it says it's in outer space or something, this is always going to be true where there's a downward force of gravity at 9.8 acceleration. Okay, so again, that's if calculations are necessary. This first 5 and 6 calculations are not necessary. I give you all the forces, and you simply have to try and draw the scenario to represent these forces and labels. Okay. Again, this is meant to be practice to get you familiar with what it should look like, and then how to label them. So I really want to see a good job with these images. Now, free body diagrams, I should say. And then I'm giving you a challenge problem and just a couple hints. Okay, what is the strength of the downward force? This is the force of gravity. I don't give it to you in the scenario, but I do give you a piece of information that you should be able to use with your acceleration to figure out the force. So again, if I give you a mass, you know the downward acceleration is 9.8. So you should be able to calculate the force. So what is the downward force? What is the upward force? Which my other hint is a support force. If you need to refer back to the notes from activity number 1, I would recommend you do that. And then last, I guess there's really 2 more, but perhaps the grand finale is draw a free body diagram representing the scenario. So you've now calculated the downward and upward force. I provided the right and left force, so then hopefully we can draw that image. And then shortly explain what does it mean. And I really want you to use the values from your free body diagram to explain the net force, and then take the net force and explain what does that mean. Is the box moving? Is it not moving? Based on your values there. Okay. As always, this is going to be assigned today on Thursday, and we'll have Friday in class to ask questions. So please get started on it. So if you have any questions, you can ask, and it'll be due on Sunday. So technically, you will have the weekend if you choose. All right. Let me know if you have any questions, and good luck.